we're gonna hope I haven't made some error in here. It's very easy to make an error while doing this. So here we go. Was gonna do this a different way, but right now we're just gonna actually write this out. I'm going to go ahead and get rid of this factor here of 2. That could be a culprit right there. And similarly, because we just multiply 2 by each side, which is 0. Now we're going to keep that. So we're gonna write this out now. A plus alright. Well, we can write to B equals 0. We're going to multiply by B. So our equation there amounts to, we don't need any of this anymore. Maybe I can speed calculate. That's our first equation. 2 equals 0. We're going to hope that I haven't made one slight error because there's no telling where I made it. If I did, it's a very tedious thing. It's very easy to do. Negative A. Absorb that. Okay. I'm going to multiply by a factor of A now. No. Yeah, that's what we're going to do. So we have our R sub R component equal to that proportionately, and our R sub 0, 0 equation is equal to that. Well, there's a negative A, and they're both equal to 0, and there's a negative A prime of second derivative of R derivative of A on each side, so we're going to cancel that. Let me actually, just for my purposes, make sure I didn't mess up any signs. bothers me that there's a. Okay, no, that's all right. All right. So we're going to equate these. Alright, well that's just, we can pull that out, and that's just a squared over 2a, but those can now cancel. I might have actually done it. No, I have messed up something. No, maybe not. Maybe. I know what the answer is, so if I have messed this up, my bad. A, B, 2B minus 2A over R equals A, B, 2B plus 2. Okay. Those can cancel. Yeah, so those can now cancel out. Oh, I think I actually did it. I did it, Tatiana.
Woo!
And this factor of 2 can cancel. Heck yeah. Yes, there we go. Okay, I did it. Okay, so we get this equation right here. Negative a, well, I'll just explain what this means. We get for those first two components to equal for consistency. Just drop my eraser. I bet the look on my face when I was like, yes, I did. It was good. We're going to add these together. A plus A hat over A plus B hat over B equals 0. Well, this is just dA over dr 1A plus 1B dB over dr equals 0. Well, we're going to integrate over r. dr equals indefinite integration. That's just going to be a constant. Equals natural logarithm of a times natural logarithm of b equals a constant. And that just means that a times b must equal a constant. Now, if you remember, A is our G sub 00 component, and B is our G sub RR component. So, when you remove the source, you want the space-time to become flat. So, in the limit that you remove the source, or that R goes to infinity, you get infinitely far away from the source. Hypothetically, I guess that's kind of a spoiler. But, it's got to approach flat space. So, at some point, this has to equal our flat space A times our flat space B, which is just C squared times 1, which means that we want to pick such that A times B equals C squared. So I'm going to write that up here. Now that doesn't exactly solve our equation. We have one more constraint that we need to solve for, and that's this right here, our third, our R sub theta, or R sub phi term. I'm going to erase that. We don't need that anymore. There we go. We're almost done, Tatiana. 0 equals b minus 1 plus r over 2 b minus a over a. Well, we already said that a hat over a is equal to negative b hat over b, so that's just plus b hat over b, and that's just 2 times b hat over b, and that cancels out that factor. So we're left with the simple differential equation to solve for b, which then we can say c squared divided by b equals a, so we automatically know a after this. So b minus 1 plus rb or b equals 0. This is our differential equation we want to solve for. Alright, now let's okay, so 1 minus b equals rb hat over b. Negative 1 r, we're going to pull that out. No. We're going to divide by 1 minus b. 1 for r. Like this. Now we're going to, let's hope I didn't mess that up. If not, we'll re-record it and we'll trim it and edit it. Okay, that's gonna solve out as that. Now let's do a over b plus b minus 1, a b minus 1 plus b minus 1. It's got to cancel. A equals a negative p. A. That's just that's b minus 1 minus b. Okay, yeah, that's right. It's constant. Minus 1b equals, that's just 1 over r, constant over r, some unspecified constant as of yet. So we can undo the natural logarithm, say 1 minus constant over r, we're going to call this constant k, equals 1 over b. That means that 1 over b, or that b of r is of the form 1 minus k over r. Which means that c squared over b equals a. We're in the last few steps here. So c squared divided by 1 over 1 minus kr is just 1 minus k over r equals a, and 1 over 1 minus k over r equals b. So now we are in a place to put this all together. We got to determine what k means. This is the form of a metric tensor caused by a source. A spherical point mass source. Okay, so ds squared equals c squared d proper time squared equals c squared 1 minus k over r dt squared minus 1 over 1 minus k over r dr squared minus r squared d phi squared minus r squared sine squared of phi d theta squared. I kind of ran that off to the side. Those I'm just going to rewrite this in another d lambda squared, where d lambda squared is just that, because it's not going to play too much importance into our... Now I need to know what k is.